In this video, we're going to study the ray model of light. The ray model of light is simply a model that allows us to represent light as an arrow. So we know that light is a wave, a form of energy that travels as a wave, but to simplify it, we can use a ray model to draw light. And again, it's simply light drawn as an arrow. There's an arrow tail and an arrow head. The arrow tail shows where the light is coming from, so from the light bulb here, and the arrow head shows where the light is headed. So here it's going towards the eyeball, so you can view it. So to see an object, it's important to understand that light has to come from that object and go into our eyes. Objects that are luminous, you can see those because light made by the luminous object goes from the luminous object to your eyes, and your brain registers an image. So candlelight, light bulbs, the sun, other stars, a glow stick make their own light that they send to your eyes and you can see them. Now, non-luminous objects, remember, they don't make their own light, but we can still see them. So the reason for that is because light from a luminous object hits the non-luminous object, like this toy car, reflects or bounces off of it, and then goes into our eyes. So if you're seeing something that doesn't make its own light, it's because there's another light source around, shining light onto it, that light's bouncing off that object, and then going into your eyes, and you can see it. Very quickly, let's take a look at what's called a beam. So here we have a light bulb or a laser and a laser, and they essentially throw out rays of light. And when you have many rays of light traveling together in the same direction, we call that a beam of light. So we have a beam from the flashlight here, and then we have a beam from the laser. Now notice that the laser is more concentrated. The beams are very close together, which is why getting a laser pointing in the eye is not good, because they're so concentrated. There's a lot of energy in one small point, whereas at least a flashlight, they're more spread out, so it's not as dangerous. Also, in a laser, you usually have one color. So the color we say is monochromatic, mono meaning one, chromatic meaning color. Whereas in the flashlight, it's white light, so it's made up of all the different colors. So we're going to go and take a look at a practice question where you have to think about a definition carefully. Is the picture below a beam? Why or why not? So think about if this is a beam of light, why or why not? You can pause the video, try it out, and then check your answer. Remember to think about the definition of a beam. So if you're here to check your work, it is not a beam. Even though there are many rays, they are not all traveling in the same direction, in one direction. So this is not considered a beam of light. So that shows you the importance of knowing your definitions to be able to apply them properly. We talk about the importance of applying knowledge, and we often remove the importance of knowledge from courses. That's not the right thing to do. You can't apply knowledge if you have no knowledge. So study those definitions, understand those definitions, and apply them in questions like this. And the only way to do that is with a little bit of hard work and a little bit of practice and exposure to the wording and to the definitions in the notes. So this is the end of the ray model of light lesson. We're going to use the ray model of light in our optics unit. So we're going to represent light as arrows going forward, even though they're really waves. And the reason that we can represent light as arrows again is because light travels in straight lines. So it's a fairly accurate representation of what's happening with light in different behaviors.